Recording in progress.
Welcome to Krishi.System. My name is Venki Ramachandran. Krishi.System is an attempt to discover systems thinking in food and agriculture in an age of runaway climate change. For a long time at Krishi.System, this was rebranded recently from Agribusiness Matters. The intent of doing the rebranding from Agribusiness Matters to Krishi.System was the fundamental conviction that today, if we are going to transform food systems, we better do it with a deeper understanding of culture. So while this was always there, but I thought the name should also reflect that. So that was the reason where I changed the name there. So we have always been doing a lot of podcast recordings with entrepreneurs and agri entrepreneurs. But I thought now is the time we start talking to farmers as well. And I'm so extremely delighted to have Abraham Chacko here, who's joining us today this morning. Thank you, Abraham, for taking the time to speak with us.
Thank you, Venki.
So I'll get started. Abraham, as you've had a very long, fascinating journey. So maybe it would be lovely if you could introduce yourself and share how did you get to do farming?
Yeah, I did my agriculture degree in 1975, 80. Then after after graduating, I started as a junior field officer in the Cardamom board. And that time my father passed away, and so I had to quit my job and return to farming. We started off in chemical farming, and we did chemical farming for 15 years from 1980 to say 1995. Then I read about Fukuoka's book, that One Straw Revolution. Then I thought that's the way forward. Then we stopped chemical inputs then, and we started into organic inputs like composting and cakes and all that. Still, the soil was not getting better. No, I could see each year the biodiversity is getting lost, like the insects, the birds, butterflies, all are going down. The soil is getting harder, meaning the soil was losing carbon. So I could identify that. Then, after doing for another 15 years, like from 1980 to say till 2000, we were doing all this, both chemical inputs and organic inputs. Then I happened to...
Oh, you're doing simultaneously two different plots, is it, parallelly?
No. The whole plot which I was managing.
Acha, how big is it, sir?
How?
How big is it?
This is around 30 acres of cardamom.
Okay, got it. And it must be a hill slope terrace kind of mode cultivation, or was it uphill or downhill?
Yeah, it's in the Idukki district of Kerala, which is the high ranges, we call it. It ranges from 2,500 to 3,500. That range, MSL.
So was it in the valley side, or is it like how was it like? Just topographically, I'm just trying to understand.
Yeah, topographically, it is grown under the forest trees.
Acha.
The natural forest trees. Cardamom is grown as a...
Yeah. No, that I'm aware. Yeah, I'm just trying to get a sense of, was it on a downhill slope kind of, or the land, how was it like, or was it...
it's a slopey land. It's a slopey land,
okay.
Moderately slopey, but it's still slopey land.
Understood. So till 2000, you were doing it in the with the combination there. Okay.
Yeah, it's grown under the forest trees, so various trees various species of trees are there. Grown. No, it's actually natural forest trees only, and we regulate the shading. If there is any overshading, we regulate the shade a little bit. So it's like 40-50% of shade we maintain. The canopy top level we maintain around 50%. If the sunlight is blocked by or 50 or more, 60% of the sunlight is blocked, or the sunlight passes through in between the trees. Filtered sunlight comes into the cardamom plantation, and we use these trees as to as standards for pepper, black pepper. Then after in 2000, I happened to listen to Subhash Palekar, the zero budget natural farming. Then while we are doing organic inputs and chemical inputs, we understood the soil is getting lesser and lesser carbon. Carbon was losing from the topsoil. So, and the soil was getting harder, and our cost was mounting the revenues was always it was going towards the minus side. So that was quite alarming. Then I understood from Subhash Palekar about the biological farming of the farming without any inputs. Then first I couldn't. I understood like it is the biology that is responsible for the soil texture and soil, the resilience of plants and all that. Then it was not. It was totally against what we learned in college and what we learned during those chemical era of farming. I'd say the agriculture is the backbone of human civilization. Initially, from hunter-gatherers, we shifted into agriculture. It was a primitive, we can call it as primitive agriculture. Uh, the last 100 years, the focus, initially when we were doing the primitive agriculture, it was focusing on physics of the soil, like the texture of the soil, the structure of the soil, etc., etc. In the last 100 years, we've the focus shifted to the chemistry of soil, like the nitrogen, phosphorus, potash, the micronutrients, like that. And we started the mankind in the agriculture. We started with nitrogen fertilizers, but few years later, we had to use potash, phosphorus. Then again, as time passed on, we had to add more micronutrients and all that. Now the cost was mounting each year, and the new pests were coming, new diseases were coming. So I was always looking for some other alternative method. That is the time I met Subhash Palekar and I understood where we were going wrong and all that. Then, as the internet came in, I started to follow certain international scientists. They were calling it as regenerative agriculture. So, after chemistry, now we understand that it's the biology that is responsible for the resilience of plants. And in the forest, there is no inputs used, but still plants are getting everything like nitrogen, phosphorus, potash, or the texture of the soil is maintained. Whatever the plant needs for its growth, it is getting. So how it is possible that I understood from uh, scientists like Christine Jones, etc., etc.
Yeah.
And the last 10 years, we are fully into regenerative agriculture. Now, that is the journey I want to share with you all.
Yeah, yeah. It's. I mean, it's fascinating in the sense multiple levels. One is that you have also seen the evolution of how because you did your agriculture education at that time. So and in many ways, agriculture education hasn't changed much, but at least in the market wise, our understanding has shifted there. But maybe I just want to start off with the history of the land. Like, how did cardamom come to grow there? Would you have some history of the land and how it actually started there?
Yeah. Actually, we obtained this farm when my grandfather was during my grandfather's younger days. It could have been around 1930s. That time, cardamom was grown as it was naturally grown here. It was here naturally. They used to come here once in a way and get.
Where were they living?
We were living in the plains of Kerala, in the midland of Kerala. It's in
Acha.
somewhere near some 100 kilometers away from here. That's below the low ranges of Kerala.
Got it.
So they used to come once in a way into this place where cardamom was grown. It was not grown; it was naturally found those days. So they started multiplying those, and like that, the farmers came the cardamom plantation came into existence.
Acha.
And till 1975, my father and all, they never used any chemicals. It was grown naturally till 1970s, 75.
But were they also marketing it and selling it outside, or was
No,
it only for
no,
local consumption?
that it was sold in here only, locally only.
Got it. Got it.
The buyers used to come and once in a year, once or twice a year, they'll come and pick all whatever produce we have, and they used to carry it. And only after 70s, in the 70s, the auctions came and the marketing was established. And now our carbon got uh, certified in the sense, the product they'll test, and ours is one of the few cardamom that is residue free, without any residues. Now we are marketing it to a foreign buyer.
You're
They'll,
exporting now to US and many other markets. No? The
yeah,
Baraka, that's
yeah,
how it's Baraka started.
yeah. Now, on foreign buyer, they came to the Spices Board. Spices Board Regional Research Center is close by, like 5-10 kilometers from here. There they came and asked for organic cardamom. Then the Spices Board people, they gave my buyer a list of organic farmers, organic cardamom farmers. They took samples from them and tested, and they found that it was all contaminated with residues. Then finally, my sample got passed their test. And from then on, they are buying whatever we produce, and they are selling it in the foreign markets. And also in India, no, India, they haven't started selling. They are still selling it in the foreign markets. They are planning to sell it in market in India also.
Yeah. No, so maybe I'll start off with a fundamental reason as to why I wanted to do this podcast, right? As I said, I visited a friend's cardamom farm in the early week of November, first week of November. And this friend was, we were discussing, he's largely practicing conventional and he's trying to move into regenerative. But what I was seeing that is that, like, at least in the common conventional markets there, it is almost seems like there is no clear playbook or pathway for cardamom farmers to do to transition to regenerative. That's the sense. Even like there are no even IPM pathways or anything also that also be not mentioned. Why has that been the case so far, sir?
Cardamom is it's a forest plant, and it is highly valued also. The produce is quite valuable also. So to increase production, people are using the lots of inputs. Like now, they're using all hormones. They're using pesticides, fungicides, nematicides. Lot of inputs, and the varieties also, the high yielding varieties which demands a lot of inputs they're using, and the production is going up in that, and the price is also still till now. Earlier it was sold world over. In the 90s, Japan stopped buying from India, then followed by Germany, then Europe, America, like that. And last year or year before last, the Saudis, the Middle East people also, they've started, they've stopped buying from us. Now, cardamom is sold only in the Indian markets. And
Because we don't have enough adequate standards.
yeah, and the next thing is the cost has gone up so high, and if they miss one input, the whole thing collapses. It is like, it's like growing vegetables in a greenhouse or something. You have to provide everything for the cardamom. Uh, so the cost is mounting each year. The price is not under our control. So, and the inputs are creating a diminishing trend in the soil carbon. So in many places where intensive farming is done for maybe 10, 15, 20 years, the soil carbon levels have reduced very much.
Hmm.
So soil
So,
carbon, if we study about soil carbon got, in the air, there is 80% of nitrogen and 0.04% of carbon. And nature will not allow nitrogen to be an element in the soil, but nature will allow carbon as a element in the soil carbon. So soil carbon in the globe is only 0.04%, while nitrogen is so abundant, like 80% of the air we breathe is nitrogen. So when we started putting nitrogen, the nature developed denitrifying bacteria to take the excess nitrogen back into the air.
hmm.
When the denitrifying bacteria multiplied, they finished off all the carbon, which was accumulated through billions of years. We are losing carbon in such a faster rate. Uh, the the condition healthy for cardamom growing is reducing each year.
Yeah, so I want to come to the science part of it, but before that, I just want to get the sense of the numbers for the cost, right? So when you were doing it in the chemical farming, could you give a sense of per acre what was like the cost? And now, when you moved into, in the current, Jivamrit kind of a biological kind of preparation based methods, what is like the cost? Can you give us a sense, a rough sense of the cost?
Yeah, at present, when we are doing the chemical farming, the cost was like heavy. We are not spending, we are just spending 10% of the cost a normal chemical farmer spends.
Okay. And
And we,
approximately how much that would be for on a per acre basis?
uh, mine cost of my production will be around 10 to 20,000 rupees an acre.
Got it. Hmm.
But in the chemical farming, it can range from 1.5 lakh to 3 lakh.
Hmm. Hmm. That's what numbers I heard also on the ground.
Yeah.
Yeah. Yeah. Yeah.
The cost is mounting. No, the labor is getting expensive. The inputs are getting expensive. So their cost is going higher and higher. While my cost is coming down as the soil is improving, my cost is under control.
Hmm. Understood.
The nature is that's the biggest part of this.
Yeah. So that's what the main part I want to get in the science for it, right? You said that nature doesn't allow,
nitrogen.
too much of
Yeah,
nitrogen beyond a point. Why
yeah.
is that so?
That's how the nature is. Nature is. No, the nitrogen will not stay in the soil. If there is an excess nitrogen, if like some manure, like maybe organic manure, also just got more nitrogen in it, nature will develop a denitrifying bacteria to take the excess nitrogen back into the air. Or otherwise, when it rains, the nitrogen gets leached out into the waterways, polluting the waterways.
No, but
We,
this was because of too much of nitrogen we put in the soil, or are you saying even overall otherwise? Like, I mean, this must have been different before, let's say, 60s, right? Like before 60s
yeah.
was still there must not have been so much of nitrogen in the air or there, right? Because of the amount of
Nitrogen was there, but we never had we never had the technology to harness the atmospheric volatile nitrogen into solid forms through urea. Only that came only after, around the 1900s. That's a very expensive process. Now the governments are giving a lot of subsidies to
yeah,
compensate the cost.
yeah. We sell the cheapest fertilizer to our farmers
Yeah.
when
Then
compared to all our neighbors. Even Pakistan's farmers pay higher money for the fertilizers.
yeah, yeah.
Yeah. Anyways, yeah. So
When
from
we
that, let's get on the science. Yeah. So how does
when
that
we
nature get
started
down?
using
Yeah.
when we started using nitrogen fertilizers, when there was carbon in the soil, it was giving good results. Now the carbon has diminished. Now diseases are coming. The plants are getting unhealthy. So more and more pests is attacking the plants. More and more funguses are attacking the plants. So we are compensating that with chemical remedies like pesticides, fungicides, which is killing the biology. In the forest, the biology is responsible for the resilience of the plants there. So we have to understand that now India government has come up with a mission called National Mission on Natural Farming. So they're aiming for that. There are a lot of other points also. When we had, plants used to get their need their need to associations with the biology, microbes, like that. And the plants were communicating to the microbes their need through photosynthetic exudations. The Panchabhutas, the air has got nitrogen and carbon. And I know oxygen is a lot of things are there, but when we are talking about agriculture, these are the two things that most important thing is nitrogen and carbon. Air has got 80% of nitrogen and 0.04% of carbon. But nature will allow nitrogen, the carbon to settle in the soil, like soil carbon. Soil carbon is the dead microbes. It is the necromass. It's called necromass. That is the dead microbes are the soil carbon, and that soil carbon holds water. Like a kilo of soil carbon can hold 8 times water in it. So when the carbon is getting lost, that facility is we are losing. So we have to increase watering and all that. If there is enough soil carbon in the soil, the atmospheric volcanic water, hygroscopic water will get held in the carbon which is present if in the soil. If the carbon is not there, then you'll have to put more and more water. Let's say,
Yeah. So is the cycle correct? Am I putting the cycle correctly here? Can you see my screen here on the left?
um,
Yeah, I'm just drawing a screen where
yeah,
excess nitrogen leads to denitrifying bacteria,
yeah,
which leads to loss of soil carbon,
yeah.
which kills the microbes also.
No, microbes, they don't kill the microbes. When there is no carbon in the soil, there is the other microbes can't thrive there because there is no water holding and air. The carbon gives two things, the aeration and the water holding capacities. So when these two are reduced, then the microbes die. So
Got it. So because of aeration and what is the other one you said? Sorry, I didn't catch that.
water holding capacity.
Acha, acha. Okay. So that directly links with because in the last call we had, you were also making an interesting point that to improve the photosynthetic synthetic efficiency, plants produce more microbes. So maybe I'm just trying to sketch that cycle here. So
Okay.
that's where I was sort of drawing the cycle here.
Okay.
Yeah, yeah.
I'll talk about the Panchabhutas, the five major
Sure,
elements.
sure.
Air has got mainly nitrogen and carbon. Okay. Water has got hydrogen and oxygen, H2O. Water is H2O. So hydrogen and except these four elements like nitrogen, carbon, hydrogen, oxygen, all the remaining elements are in the soil in an unavailable form. All the 104 elements like potash, all those 104 elements in the periodic table are soil. Soil is a compound of all those 104 elements. Okay. Sunlight has got gives the energy, and only plants, the chloroplast in the green leaves, it's like a solar cell. A leaf is like a solar cell. The chloroplasts are the solar. What do you call that? Solar that cells.
Okay.
This chloroplast can convert the solar energy into a biochemical energy through photosynthesis.
Okay.
Okay. Till 2000, humanity never knew that the plants can exudate this, a part of this carbohydrate is exudated into the soil to the benefit of the microbes or for energizing the other lives, the microbial life. Before 2000, we thought When a leaf sheds, microbes are shared with the energy that is stored, the solar energy, converted solar energy to the microbes. 2000 only, humanity, the scientists found that plants are exudating 30 to 40% of their photosynthetic exudates into the soil through their root hairs, through their fruit. And by 2010, 15, the scientists understood that plants are not doing it, plants are doing it for a reason to communicate with the microbes. Okay, when a plant needs nitrogen, it will feed the nitrogen fixing bacteria. When the plant needs potash, they will communicate with the potash solubilizing bacteria. It goes on like that. You know,
So the root exudate will be the communication device that will say
yeah,
what nutrient is needed, and then based on that, the microbes will
yeah,
microbes will act as employees for the plant.
exactly.
I'm just trying to put in simple terms so
Yeah,
everyone understands.
yeah,
And then this microbes will, based on the signal that gives in the plant in the root exudates,
yeah,
microbes will go and collect different nutrients, and that is where that is also the reason where some of the plants don't move also. No, so how does
yeah,
movement affect in this?
yeah,
Because Christine Jones talks about movement also. No, yeah,
yeah. Okay. So nitrogen is not in the soil. It is in the biomass.
correct.
But there is enough and more nitrogen in the air. So this communication is very much necessary for obtaining nitrogen for the plants. Okay. Then when we are giving the plant nitrogen, the plant doesn't have to communicate to the microbe. This,
Okay.
this communication happens through the photosynthetic exudations. So when the plant gets enough nitrogen given by us, the plant will reduce their photosynthesis. They don't have to communicate with the microbe for nitrogen. We have already given the nitrogen to the plant
Why is that so?
because the plant needs a certain amount of nitrogen. So we have given that nitrogen, then plant doesn't have to communicate to the microbe for more nitrogen. Plant doesn't need nitrogen anymore. We have already given the plant some nitrogen. So they'll reduce their photosynthesis because they don't have to communicate with the microbes. So now, here and there, people are talking like the global warming, the main reason is this nitrogen application to the plants. Because there is abundant nitrogen in the air.
Yeah, and it gets leached out in soil and in the waterways, especially
Yeah,
which
that
leads
is
to
another
NO3 pollution also. Yeah.
yeah, that is another thing. So
So,
everywhere where photosynthesis happens, even the algae photosynthesizes. They all for photosynthesis main photosynthesis in the main object of main object of photosynthesis is for obtaining nitrogen from the air, which is not in the soil, which nature doesn't allow nitrogen to be an element in the soil.
I think it may. I'm just putting out this major point because you're mentioning a very important point. I'm not many people may be aware. I think plants absorb more nutrients from air rather than from the soil. That is the
Um,
fundamental lesson, right?
no, plants get the nitrogen from the air mainly
Correct.
through the association with the microbe. The potassium, phosphorus, and all the remaining nutrients are in the soil. The soil is a compound of all these 104 elements. But
Okay.
the
Okay.
plant cannot obtain it directly. Plant needs an intermediary function of the microbes, potash solubilizing bacteria or phosphorus fixing bacteria, like that. There are a set of microbes are responsible for each element which is in the soil. So the plant has to
Understood.
communicate with those microbes to work and get it for the plant, solubilize for the plant.
Okay. So, sir, I just want to also step back a little bit from the plant biology and also look at, like, when 75, when the high yielding varieties were there, right?
Yeah.
In what ways did they contribute to the challenge there? Like Apangala, and there are multiple varieties we hear, right? In the 70s, what was the variety particular that was right? I mean, now I see Icar really launching Vijeta, Vinash, many, many varieties I'm seeing. Ikri also has a lot of new varieties.
In cardamom,
Yeah, in cardamom only I'm saying.
Okay. Yeah, they are all mainly selections, different selections.
So I mean, I'm just asking from the sense of, did the introduction of any particular variety lead to sort of this trend, or did the older varieties didn't survive the current conditions, environmental conditions?
Yeah, we are talking about the microbes and the interactions, no? So
Correct.
the microbes are passed on to the next generation through the seed. Seed will hold certain microbes. They are called core microbes. Core microbes. There are two types of microbes, like core microbiome microbes and associated microbes.
Okay. Okay.
And this too happens in the rhizosphere. Rhizosphere is the root zone,
Okay.
the area around the root zone. So the core microbiome starts from the seeds, and they will interact with the associated microbes, which the microbes are in the soil and the other one. They both will associate together, and they do the job. So in a new variety, the core microbiome may not be there. There again, we will have to supplement. If the core microbiome and the associated microbiome, if they interact perfectly, there won't be any need for inputs or assistance. Nature will take care.
This is a
So
very fascinating point. You're saying that in newer varieties, the core microbiome is not there, therefore the additional input there, right? Because you were also telling when the last call we had, you were telling about this part that earlier in organic and other methods, right? Like, because Fukuoka literally talks about saying do nothing farming, right?
yeah,
But that I presuppose, but we can't directly literally follow that advice, right?
yeah,
So
but
what has been your learning there?
um, it's we have to uh, improve the core microbiome. Core microbiome. We can select the plant for resilience of certain pests. If some pests attack, some pests will not attack pest-resistant varieties. We were all
Did we lose you, sir? Okay, I think we lost you. 1 second. Huh?
Recording in progress.
Yeah, sorry. You were starting to tell about the associative microbiome before you had a power cut unexpectedly. Yeah, so if you could just continue that thread, sir. Yeah.
but the new varieties, no?
Yeah, yeah. So basically, I was just trying to get a sense of, was there a significant dip in productivity with the new varieties, or like right now you told me
So
that you use new varieties and the older ones. So how are they contributing to this? Is what I want to understand.
the seed, not the plant, the planting material which we use should have a core microbiome which can associate with the associated microbiome. So if they are new to, if a new seed is introduced into a field, you have to give it a little bit of time, or the research has to come up. Here in our farm, we are using the indigenous varieties. We were using all the advanced new varieties, which are very high yielding and all that. Then we replanted it with the indigenous varieties, indigenous selections. In modern agriculture, we were always selecting plants for their yield only. We are not in cardamom and all, only about the yield we were considering, not about the resilience to some pest and thing. If there is any pest attacks, we were addressing it with inputs, pesticides and all that. So that is a change which I understood. And, we are doing that, we are making that change into practice, like
Yeah,
with
so
the indigenous variety.
just to clarify, so you're saying that when we use indigenous varieties, the interactions between core to associative microbiome is happening in, whereas in the
Yeah,
other varieties that is interaction is not happening.
yeah,
Is my understanding correct?
exactly.
Okay, all right.
That is what is happening. That's the best way to. Our focus for selection should change. It should not be only yield. It should be the resilience. We can do it. What happened in Cardamom area is that when the high yielding varieties like Nyalani or some new varieties came, everybody went for that, and the diseases were there, pesticides were there. We addressed it with other inputs. So
So,
it's like
yeah.
we have to focus on the biology, which is the core of agriculture, core of agriculture. Say the microbiology comes through the excreta of organisms. The microbiome of their gut, gut microbiome will convert into their soil microbiome through their excretas. Like cow dung, the cow has got microbiome in their guts. The cow dung represents that microbiome. Like that, each insect, each bird, each organism, they they form another set of microbes. Like when soil is passed through the gut of the earthworm, the earthworm gut microbiome come into the soil through their excreta. Like that, each
So,
animal each organism is, that is why it is called biological farming. This is the focus of tomorrow. This is going to be the focus of tomorrow.
yeah, so can you
Like,
give me specifics on how you prepare your inputs, sir? Like maybe if you could give that sense
no,
also, it
no,
will
we have
helpful.
some cows. We have some cows, the indigenous cows, the
Which
desi,
variety?
the desi cows, the Bos
Acha.
Indicus cows.
Boss Indicus, okay?
Yeah, Bos Indicus and Bos Taurus. The gut microbiome of Bos Indicus is much superior to Bos Taurus because Bos Indicus cows evolved in the temperate tropical zone, while
Yeah, so
the Bos Taurus cows evolved in the temperate zone. Temperate zone, there is very little diversity of plants, and the lignin content of those grasses are very a lot of microbes to digest all that. But the Taurus, the Indicus cows, they live in coarse fodder. So they and very tough, high lignin content fodder, and they have a diversity of fodder here. So they naturally developed a lot of diverse microbiome in their gut. So their cow dung is much superior to the Taurus cows. So we use Bos Indicus cow dung, and Subhash Valikar's contribution is that Jivamritam. Through Jivamritam preparation, that technique, we are multiplying the microbes in the cow dung
so
to
you soak it,
1,000%.
add jaggery and do all of that process.
Yeah, yeah. Jaggery and the flour and all, it's the energy for the multiplication. It is the energy for the multiplication of the microbes. The focus is the microbes, increasing the microbes. Like, during our Green Revolution era, we were not allowing the biology to thrive. We were applying pesticides which will kill all the insects. The insects had the role of pooping or excreting the microbes into the soil. Like that, the microbiology was developing. We said no to that. We were removing all the weeds, thinking that the fertilizer will be taken off with it. So the conversion of solar energy to biochemical energy was getting lesser and lesser as the green cover was going. So the
No,
solar
so
energy for the multiplication of microbes was diminishing. These were the things that happened in our agriculture. And application of nitrogen, again the conversion of solar energy into photosynthetic biochemical energy reduced. Like that. No, it's nobody's fault because Humanity never knew before. Only after 2000, some new findings of liquid carbon pathway and all those came only in 2000. And, it took another 10, 15 years for the scientists or the humanity to figure out how the nature works. So,
Yeah, but today, sir, let's say I'm a conventional cardamom farmer, and I come to you saying, "Sir, help me transition." How would you plan my first initial 6 months, sir? How would you tell me, suggest me to do the transition? Because see, there are also people who are listening to this podcast, like even Tarun, who's joined here. His parents are from who are growing conventional cardamom using chemicals. So Tarun has joined this call because he wants to convince his father, who is not yet convinced about shifting to true in transition. So I'm just asking this on behalf of them in terms of if we were to sort of make a plan, because right, there are a lot of fears that comes in, right. One is that immediately when you transition, your yield drops. Some I know of farmers who have avoided that, but largely this
yeah.
is the concern everybody has, right. So if one has to do a
I,
transition, what should one do?
yeah, I think we should understand how much carbon is left in your soil. It's getting to soil is a very long process. So if the carbon is very low, you might need little bit of inputs, you know, to increase the carbon. It is not the nitrogen or phosphorus or potash or anything. It is there, but we need the biology to handle that. But to improve the biology, you need a considerable amount of carbon in the soil. So, and we have to shift to, we have to understand how the carbon got lost. Then we have to uh, change our approach to a method so that the carbon will flow into the soil, not out of soil. No, nitrogen is enough in the globe. Potash, phosphorus is there where the plants are already established. In the deserts, the techniques might be different. So, it's we need to learn a lot about this, and from traditional agriculture we shift to the green revolution. We were applying all synthetic inputs. Then the input shifted to organic. Both are the same. It's the chemical era of agriculture. Now we are thinking about the biology of the soil, the life
Yeah,
in
no,
the
no, I
soil.
understand. But from could you give maybe a transition plan as to how what has happened based on the soil carbon?
Yeah.
Let's say the point today, right now, on average, India soil organic carbon is about 0.2 to 0.3. So from that, what is the level at which we have to go to right now for a
Yeah,
good
we have to
thriving?
the selection of plants. One thing. The
Okay,
selection
so
of
first is
plants.
soil organic carbon, then selection of plant. What varieties would you recommend when somebody is in the transition?
And then we have to improve the conversion of solar energy into biochemical energy. That is the energy
Okay,
for the microbes to work and feed the plant, build the soil.
okay,
So these things, and you get a little bit of like considerable amount of like maybe 3% soil carbon. Once you reach there, things will be it can depending on the variety, the yield can go back.
So,
Yes.
would you recommend immediately switching the varieties or continuing and improving the soil carbon and then doing that?
It has to go simultaneously. We have to get the suitable plants, which are suited for that particular soil. Any crop it is possible. You
Okay.
know,
So, could you give also a sense of the like the whole fear about yield loss?
yeah.
How did you manage for that? Could you tell on that? Share on
Um,
that?
that is a long story. I was like, I became an outcast among the Cardamom farming community. Although I did my agriculture graduation and all that, and I was considered as a gone case, nut, kind of that. But while I was working in the spices board, in the cardamom board, I saw some farmers living inside the forest, the tribal farmers inside the forest. And my objective visiting them was to convert them also into chemical farming in those days. But they adamantly said, we don't want all that. Nature will give. That stayed in my brain.
Which year was this?
That was around 1980s.
Okay.
When and I was doing farming and I was failing, I failed in synthetic input farming and organic input farming also I failed. The cost was so high that I couldn't be at peace. Then I learned the science behind regenerative farming from Subhash Palekar, and then that got validated through the scientific studies of Christine Jones and Elaine Ham and all those scientists. I was following and I was practicing and I saw the results. And slowly now, it's a very evolving science, a paradigm shift from chemical to biology. Now I truly see the benefits. It's so cheap, there is very little risk. Otherwise, cardamom, one mistake, one input you don't apply,
Correct.
everything goes. It goes for a sixer.
Yeah. I know.
It's
Yeah.
you are never at peace. You're every day you're fighting with something or the other. Yeah, your life is gone. Maybe you'll make some money. You'll count a lot of money. Like when you sell, you'll count a lot of money to your pocket. The next day you'll take that money and count it back to the input industry. So it goes on like that.
Yeah.
There's no peace.
But could you give a sense of the how the yield shift happened? Like yields plunged down when you do the transition. How did they bounce back?
Now my yields are never matching with the modern intensive farming.
Okay.
It's around 100 kilos an acre. That is all. While the others are getting like 500 kilos an acre.
So you have to then prioritize the quality and that part
Yeah,
over
but
the quantity.
I got lucky to find a good buyer. So they give me double or triple the price of conventional cardamom. So if my yield loss is so much, the price is like double.
Yeah. So one thing I also want to ask, as I was telling you in the call prior to the call, I'm having this book which is a guidebook that was published 120 years ago.
Okay,
In that, there is a chapter on cardamom
okay,
where there are a lot of intercropping is being discussed
yeah,
with Parker trees and
yeah,
all of the Parker manam and all.
yeah,
So, do you follow intercropping or in cardamom because typically it's around grown around forest trees, right?
yeah.
So, would intercropping be of help? How do you see that?
Yeah, that's how those are the possibilities. Those are the possibilities. In our case, we are using the trees as a standard for pepper, which is also another crop which can give you without
So, you're
any.
also harvesting pepper?
Yeah. We do a harvest pepper, then we intercrop with ginger and turmeric.
Okay.
In the initial
In the book, he talks about intercropping with ginger also. So,
in
that
the
was done
initial
100 years before. Yeah.
Yeah, in the initial years, we intercrop with cardamom, pepper, and this ginger, and again, those are the indigenous varieties. I got my turmeric rhizomes from the forests of Idukki.
Oh,
Yeah,
okay. So
uh,
you took it from that and then you started propagating it.
one of my uncle was extracting curcumin, and he was
ठीक है.
getting his turmeric from the tribals, which
अच्छा, what are the curcumin levels there?
it's around 5.5,
अच्छा, okay.
and it's the indigenous variety.
Hmm.
That's the important thing.
So
Because the
you took
core,
that and then you started growing it from there.
yeah, unknowingly about the core microbiome and all that. But now I understand the turmeric. We don't have to do anything. You just got to take it out from the soil when it
So
is.
how do you plan the crop calendar and cycle, sir? So like when do you start? Let's say you have a new land or new piece of land. How do you do the intercropping cycles like?
And this are connected with the solar calendar.
That's what I wanted to get into. How
Yeah.
do you look at do map the solar calendar?
There are two times when the sun is very close to Kerala, the south. Like one comes in April, May. That's called the Medam Pat. The other one. That
You
time,
tell me in Malayalam, it's okay.
Medam Pat. Medam Pat
Madam
is,
Pathu.
yeah.
That is a star date, a moment.
Yeah, and that depends on each crop. In a cardamom, we start on that particular day. The planting starts on that.
Okay, so that day you start the plan. So you draw the almanac also.
Excuse me?
You draw the almanac, the traditional calendar. You use draw that and sketch which day to plant based on that.
That, the calendar, it is written, the Malayalam calendar is also written in the side of
Okay, so
that.
you just follow the Madam Pathu and then you do it. So Madam Pathu is a particular day, is it?
Yeah, that's
Okay.
sun is the closest to Kerala.
Acha. So on that day you start the plantation.
Yeah, in Cardamom. And
Okay.
ginger and turmeric, we don't, we'll plant any time, whenever the rhizome is ready, we just broadcast. And pepper, the planting is done in around June, July time. There is a particular date, a particular week. In the calendar, I know the dates in my mind. And the next time, Cancer and Capricorn, there are two ways for the sun, no?
Correct. Tropic of Cancer, Tropic of Capricorn.
Yeah.
Yeah.
One is Madam Patta, the closest, and Kanni Irvattar, the other side.
Kanni 26, okay?
These two times the sun is closer. So when
Okay.
the sun is closer, the sunlight energy is more here. So that time we try to increase the biology, like applying Jivamritam and all that. We increase the biology so that and the plant and the microbe will become a liability for the plant to give more energy for the microbe. When the sunlight is
Yeah.
more of solar energy is converted into the biochemical energy and exudated to the microbes. Like that, the biology flourishes.
Yeah, I think I'll just highlight this point. I think because it's a very super important point, because you're saying increase in photosynthetic efficiency leads to more microbes.
Yeah. Yeah. Or, it's like a circle, no? Uh,
Yeah.
so when there is more sunlight, the plant can convert more sunlight. So the microbes will get more of biochemical energy and they'll produce more and give it back to the plant. Like
But
that.
tell me one thing, why is the planting date? That part I have not fully understood clearly. So why is the planting date has to be on Madam Bhattu? Is it
Uh,
because the sun is higher? That is why it is there?
no, that is through the observations from the the traditional knowledge, the old knowledge, the old people.
So what have you learned from that? If you could share
Yeah,
more
I
on
think
that.
it is connected with the sunlight energy and photosynthesis.
So
It
are
is
there like studies that collect on that day? Why is it? Why it should be planted?
that all, the scientists will have to figure out.
Yeah, no,
And
I'm saying from your observations, since you're saying it's a traditional knowledge, so was it passed on from your grandfather or
yeah. It is from the workers, the old time workers, they'll say, in those days, when we plant in that time, the yield will start in an year. Now, if you go further, like 2 months ahead, the yield will come only after 2 years.
Okay. Yeah, because in
The,
this book also he says that after planting 1 year you should be able to get yield. In the book it says, yeah.
mm, the olden days,
Okay.
the old traditional knowledge from, this all, although they don't have any scientific explanation,
Yeah. This is
it is all,
Shastram. Shastram and science are all same only, sir.
yeah, it
Similar
is all
only.
connected with the Panchabhutas. It is all
So can you
connected with,
explain a little bit more in terms of how the how the Panchabhutas are connected with this traditional knowledge and how what role they play? Because we all know Panchabhutas from a very religious sense.
yeah,
From in this sense, how is it connected?
it is like nitrogen and carbon is in the air. Hydrogen and oxygen is in the water.
Yeah, this point that you mentioned earlier. Okay.
Yeah. The remaining all the elements are in the soil. And those elements cannot be taken directly by the plant. The nitrogen has to be fixed by microbe. Potash has to be solubilized from the soil, has to be solubilized by a microbe. Then only the plant will grow. And all this life gets energized through the photosynthetic exudation. That is the
Yeah. No, this you explained it very clearly.
that is the
So,
sunlight.
apart from the Medam Pattu and Kanni 26, what are other traditional learning practices that you follow in your cardamom plantation?
Then during that Kanni time, if you can induce the tillering,
Okay.
again,
Okay.
again it's connected to the sunlight.
Okay.
More sunlight energy is falling into the earth, and if there are plants that will convert that into biochemical, more microbes will come like that.
Okay. Okay.
The growth will be more, the tillering will be, accelerated for the next year's crop, like that.
I see. I see. I see.
It's a vast knowledge, I'm still learning. I'm still learning.
Yeah. Yeah.
I'm
Yeah.
still
Yeah.
learning. And, the science is also validating new things. Like, previously, we never knew about this liquid carbon pathway. Now they say about the rhizophagy, a new science, that the microbe will enter into the plant and give the nutrients. It is not through osmosis is there, RTP is there, but the third force is coming. The microbe will enter into the meristem and give the plant the element, and then it will come out and fix more of that and enter into the plant. That's the rhizophagy. That came around 2020. That's a latest study.
I
And
see. I see.
they will settle
So
in the
you
cell.
discovered this through Christine Jones, her paper, is it?
No, here that was discovered by James White.
Acha.
James
Okay.
White.
Could you explain that
Nice.
part? I didn't get that fully clearly. What he's saying
The
that the
news.
microbes will enter from other plants and enter inside to the plant.
No. The microbe will end up into the root, inside the plant.
Okay.
Okay, the nitrogen fixer. The nitrogen they'll fix, and the microbe will hold the nitrogen and enter into the plant and give the nitrogen to the plant, and kernel will come out. That's a new science. And also
Wow. Okay, and they'll come out also.
yeah, they come out also. And some of them
Acha.
stay inside
Interesting.
the plant also. And that will become their core microbiome.
Interesting. Very interesting. Okay.
It's a paradigm shift to the biology of.
Yeah. But when they come out, where do they go?
No, they go back into the soil, then or the air, then they'll accumulate the element and get in back. And they have only 20 or 10 minutes, few minutes life only. In that,
Wow.
it's going so fast, like a highway or something.
And you said rhizophagy, yeah? I'll look this up a little bit
Rhizophagy.
more. Rhizophagy, okay.
Rhizophagy.
Yeah, no, I think the mycorrhizal bacteria itself, they were doing a lot of studies, and there a lot of new science is
Yeah.
coming in.
Yeah. The
That side
mycorrhizal
also, yeah.
bacteria, they are like the electricity connections in a city. From a power plant, it's coming to your place. The electricity is coming. The water is from
Interesting.
a water tank, it is coming to your. It's like that. The mycorrhizal function is like that.
Interesting.
And again,
Very
the
interesting.
mycorrhizas, when they develop, they give a lot of carbon back into the soil. They produce something called glomalin. The filaments, the mycorrhizal filaments, are covered like our electric plastic wires. No, inside the filaments are there. It's covered with plastic. So a product is produced by nature called glomalin. That is a very high carbon compound.
I see.
So when we are digging and when we are applying nitrogen, this mycorrhizal, when we are giving everything to the plant doesn't have to form mycorrhizal networks. That will again reduce the carbon into the soil.
Yeah, we are not giving work to those employees
Yeah,
called
yeah,
microbes.
Yeah. The Panchabhutas are all interconnected. That interconnections, we are using our technology, our brain to, for our benefit only we did that, but we never considered the
We will not
Panchabhutas.
let them take the takeover.
Yeah, yeah. We killed every microbe. We started killing all the micro insects, plants. The Panchabhuta symbiosis, we hindered in between. You know about the Vasudhaiva Kudumbakam?
Yeah, yeah, yeah.
Okay, Vasudhaiva Kudumbakam, it was an olden concept in Indian philosophy.
Correct.
But in the Western philosophy, a similar word is called holobiont.
Yeah,
Holobiont.
Christian Jones talks about holobiont. Yeah, yeah.
Holobiont. That is exactly the Vasudhaiva Kudumbaka concept.
Interesting. I never linked Vasudeva Kudumbakam with holobiont. Okay. How are you saying
Holobiont.
that it is interconnected?
Because we consider everything as our partners, as a Kudumba.
Yeah,
The
yeah,
microbe is
yeah.
your Kudumba because the
Fascinating, sir.
microbe is inside you. The
Yeah,
microbe is
yeah.
inside a plant. So the plant and you become a related through the microbe. Like that, the Vasudeva Kudumbakam is existing. I don't know how the Maharishis in those days they found out all these things.
Yeah, yeah. I know we've been speaking for an hour. I just want to open up the floor. Shrikant and Tarun, you want to have any questions?
So good morning. Srikanth here. Uh, I just had a question on the microbes part you were talking about. How
Yeah,
do
yeah. Go
we
ahead, Shrikant.
gauge what microbes are needed, or are they sufficiently in the soil or not? I mean, assuming that we have used pesticides and have reduced the microbes. My point is now, if I want to recover the microbes in the soil back once again, firstly, I'll remove the chemical residue and the chemical nature that I'm providing to the soil. I'll reduce them. That is a given part of it. But secondly, how do I ensure that the microbes that I need for the plant are being grown or nurtured in the soil? Because every plant would have their own set of microbes that will be needed for the highest productivity. I can't have a tall growing plant microbe used for a good root plant. So how do I ensure that, or how do I study for that part?
Okay. Thing is that 99% of the microbes are not yet classified. Only 1%, we know about only 1% of the microbes. And when we learn about 1% more, 1% is mutated and coming as new ones. So we can never understand understand fully about the microbes. Till now, we have whatever the common notion is that mankind has only understood about 1% of the total microbes. So we cannot say beneficial microbes and pathogenic microbes like that. Now we have identified 1% only. From that, we have found some are pathogenic, some are beneficial, like that. That is, we have to understand that, our limitation. We have understood very little. We know very little. The next is that how we can increase the microbial beneficial microbe. The microbes are all connected with plants. Like a particular, like a tapioca or a carrot will be feeding a set of microbes. Cauliflower will be feeding another set of microbes. A maize will be feeding a set of microbes. The rice will be feeding, plant will be feeding another set of microbes. So to increase the microbial populations, we got to increase the diversity of plants. The more diverse the plants are, the more microbes are fed with or taken care of. So when you increase the diversity of plants, the diversity of insects increases. When the diversity of insects increases, the diversity of microbiology increases through their gut microbe.
Sir, a point.
Through the gut microbiome of the so whatever agriculture we do, we have to increase the diversity.
Sir, a
Earlier
point
we
to add.
were,
Sorry to interrupt.
yeah,
Sir, right now, what I'm looking at it, what you're telling, we have got soil. But there is also another part, that is the soilless farming, vertical farmings and stuff, right?
yeah,
Over there, if we are looking at it, uh, obviously there is no soil, cocoa, peat, and every other things are being used. I haven't dwelled much deeper into it, but obviously I don't think microbes are being used over there in that sufficient quantity wherein soil farming is done. So over there, the yield is still at a higher side. Can we relate these two, or can we say there is no connection over there? Venki, I'm sorry, I may be going
no, no,
out of the topic or something.
you're asking a doubt. We'll discuss about that. We'll debate on that. Like vertical farming and
Because sir,
monocultures and
there are no microbes over there. I would assume because there is no soil. Because it could be entirely
yeah,
hydroponic farming, entirely under the water, no
you know,
microbes.
the
But still the
produce
yield and
produced
still the
from that
organic
will be.
matter is there.
Yeah, no, there are few assumptions in this, so I think we'll have to go through that. See, one is, I'll let sir answer there, but just very briefly, I want to touch upon that. The problem in that is the nutrient density in that is a bit of a challenge when you just add,
Yeah,
because there you're adding synthetic inputs. All the inputs you get
like
added in hydroponics in the water, and then so the every nutrient that the soil plant is growing is comes directly from external inputs.
like
Yeah, but sir will add
what
more. Yeah.
what our grandfathers ate. We have to, if we want to compensate the nutrients they got, we have to eat 10 times more they ate. Still, some of the vitamins are totally absent. That means it's not there at all. There is no way we can get to obtain those vitamins.
Yeah.
So
See,
that is the
yeah, see the
quantities. It's not the bulk; it is the vitamins, the nutrient density we have to think about. That is the only way to for our health and the animal, the biology, the life of the biology needs health. We have to think about an healthy ecosystem. Then only we can survive. Otherwise, nowadays, a lot of youngsters are got very diminished health. Physically, maybe they are. Their mental power, a lot of other things, their capacities are reducing.
See, the only point, Shrikant, in most of the, I have worked with a lot of vertical farming ecosystems. Uh, they do synthetic dosing of nutrients, and that synthetic dosing of nutrients is integrated as a part of the fertigation practices that they follow. So that there is a lot of significant cost of that, and that leads to higher yields there. So there, of course, microbes are not playing the role, whereas plants, as I said, we discussed in the call, plants engage these microbes as employees who do this nutrient selection naturally and automatically from the soil there. So, but yes, your point around whether there is microbe in that, I'm not too sure if there, but maybe I will also look this up and see if there are studies that measure the microbes in a very soilless with cocoa peat kind of model vis-a-vis a very soil model. I'm doubtful, but we'll see. I'll check out and let you know.
Yeah.
Uh,
What we can do is we can, in a vertical farm also, if we can plant at least 10 different plants together. Like some could be like, like a beetroot and a carrot grown
Correct.
together,
Yeah.
a mint
Yeah.
and a tomato and a brinjal grown together, giving space for sunlight.
Yeah, that experiment you can do and see. Yeah, but typically in
Yeah.
vertical
And
farming, people
in
don't do multiple
between, we
varieties.
can think about some other plants, some other, like, if we can, St. John says, like, if some six plants grown together, it's something okay. And somebody is saying, like, if you can put 30 plants together, you don't have to think about anything. They'll grow on their own. But you'll have to find out the companion plants that can be grown together. All those things, the future science is going to tell us how it can be done. We can also think about, we all can start doing the companion experiments and all that.
Yeah,
You
yeah,
know, a lot
yeah.
of things has to be studied. You know, it's an evolving science, and it is started maybe after 2000. I should say the paradigm shift uh, started after 2000
We
towards
are
the
still at a
biology.
very early stage in our evolution there.
Yeah,
Yeah,
yeah, we are in the early stages. The biology of
great.
this. You know,
No,
all
but
this.
yeah, do try out the experiments and and then we'll have to see
Yeah,
that.
yeah, I'm getting old.
Yeah.
I'm around 70 now.
No, I'm not talking about you, sir. I'm talking about Shrikant.
Okay.
Yeah, but thank you so much. It was such a wealth of information there, and you very generously shared with us.
Yeah, yeah.
My intent in doing this in open, I actually made invite for open for all. Generally, I do these meetings in a closed room, but this one I'm very eager that many people understand and are aware that this transition is possible from the chemical to a regenerative mode, and that's the reason where I decided to do this as an open event, and this video will go to a lot of people. So I'm hoping many of them will learn, and hoping many of them will reach out to you also to learn more. Some of the cardamom friends, farmer friends I have in touch, they have already taken your number. So after seeing this video, I'm sure many of them will reach out to you. So I'll, but yeah, any last words? Anything that you said you are 70 there. So how are you making sure that the next generation is taking what you have done so far, sir?
Yeah, my kids are all convinced. At least
Super,
they are
super,
happy. So they are
super.
all they are all abroad, and one is in Bangalore, one is in Kottayam, one is in US, like that. So they'll all come back. They comes occasionally, and they stay with us. They are very much interested.
Very
And
nice. So they will eventually come and take over
yeah,
and give you a break also.
100%. So far, 100%. There is no way out. Way out for humanity. Go back to agriculture. That also understanding the physics, chemistry, and the biology.
Yeah, yeah,
And we have to, we never thought about the biology till now.
correct.
Now we have to do a lot of studies on the biology, how the biology is helping the physics and the chemistry.
Hmm. Hmm.
That is the regeneration. You know,
Yeah, yeah.
we have done a lot of harm to the physics of science, physics of soil, the chemistry of soil. All that can be put right through the biology. And for the biology to thrive, we might need some knowledge to regenerate the physics, regenerate the chemistry, like that. It's again the diversity of plants. It has to start from the diversity of plants.
Yeah, yeah, yeah.
And
Absolutely, sir. Yeah.
the indigenous microbes, indigenous varieties got uh, uh, the old microbiome in them, the seeds. So if we can introduce the indigenous varieties, the indigenous microbiome can be introduced back.
Yeah. Are you maintaining a seed bank also, sir?
No, I am yet to, I do have little bit, I'm an old man, no, one man show.
You don't look old, sir.
So the things are getting, I recently, 2, 3 years back, underwent a stroke. So a lot of difficulties are there.
Okay. Yeah. But I hope there are more youngsters around you
Yeah,
will
I'm
come over
ready
and
to
take over.
teach anybody who comes here. I take them around the field the whole day. Talk to
Okay.
them.
I will come one day. I will come once and
Yeah, because
come
I
and
want,
learn.
whatever I've learned or whatever I'm learning, I
Yeah.
want to share with everybody.
Yeah, no, I am starting this series, sir. So apart from cardamom, any other farmers who have transitioned and are willing to share, I want to do this for every commodity,
Yeah.
every crop. So
More,
do connect me to other farmers
yeah.
who have done this transition successfully.
Do you know about the NMNF, National Mission of Natural Farming? The Modi
Yeah, yeah,
government
yeah,
has
yeah.
come up with a
Yeah, yeah, yeah.
mission, no?
Yeah. I do work with some of the policy governments also. Yeah.
Yeah, there is a lot of resistance towards that from the input industry. Try to support them.
No, we are doing our best, sir.
Yeah.
We were involved in the natural farming certification body.
Mhm.
We shared some recommendations and we were reached out. I'm working with the ecosystem primarily to strengthen some of these and help the farmers do the transition and also create the policy structures that enable this transition. So
Yeah.
I'm actively involved in that. This video was also created primarily to help a lot of farmers who think that it's not possible. I think to show them that this is possible and you can make a lot of money. You may not be growing the same level of yield, but you'll have better buyers who can pay at least twice or thrice the price.
I should say the carbon in the soil is the real wealth.
Correct, correct.
Soil carbon is the real wealth.
Absolutely, absolutely. We've lost that wealth, and that's why we are
Yeah,
now going for other wealth. So yeah,
yeah.
yeah, yeah.
Hi, sir and Venki. Just a question. Would you be willing to uh, put on some points? Would you want to stop the recording for that point, or shall we continue in this part itself? Are you
Yeah,
okay
yeah.
with it?
What? No problem. No, no problem. Go on.
So basically, sir and Venki, so basically, I'm an engineer and I want to start my own farming. So I've been started working with 11th and 12th biology and stuff. Physics, chemistry, I'm pretty good at it, but that's another part. So right now, what I'm looking at is maybe say vertical farming. I'm looking at crops that are being sold uh, at a higher price in the mandi, at the dairy rates, and go back and look at what crop should I look for. Right now, looking at your seminar right now, I could understand that a vertical farming may or may not be possible. Say I was looking at turmeric from the Pune. I am in the Pune part, Maharashtra. Now, if I were to start with a low capital, because nothing is impossible, I go by that thinking that vertical farming should not cost everything. So, if I were to start with a low cost, how should I proceed? First is the education, second is the capital. Could you both guide me on some of it? Because
Sure,
I
sure.
need to
No,
start
that's
on a trial basis or a pilot basis. I'm not going to quit my job or directly jump into it because I've got no prior experience.
yeah, yeah, yeah. I
Could
understand.
you
I
guide
understand.
on
I
that
work
part?
with a lot of people like that. Yeah, yeah, yeah. See, I will suggest you one thing, Shikant.
Hmm.
Initially, don't think about buying the land. Okay.
Hmm,
This
hmm,
is
hmm.
my suggestion. Then I'll ask Sir also to talk about it, share his experience. I work with a lot of youngsters who are doing this transition. What I tell them is you don't have to quit your job. First, start to go and work with farmers. In many parts of the country, there are a lot of weekend farmers groups that are there in many cities. Join some of those groups. Volunteer in weekends. Go to those farms. Start working there. Get the understanding of uh, you know how it all things are working in practical terms. Okay, right now from the distance it all seems rosy and romantic. When you
Yes.
come closer and work the ground on the ground, you will see the real challenges. So start working on the ground in weekends, at least start doing that work. Once you start working in, you should be able to get a small piece of land for you to do your own experiments over time. Once you build relationships, today it is possible to get a small piece of land if you build sufficient relationships. You don't have to buy any piece of land. You just have to work out the right terms with some farmers who may be willing to give you a small piece of land to do your own experiments. But for that, you have to build that relationships, and for that you to build that relationships, you have to go and work with the farmers in different parts of the country, earn their trust, and then figure out ways there. So once you do that, you don't have to start, because the moment we have the idea that I have to own all the land and then do farming, that's not needed right now. Right now, you is very well possible. I have enough stories. Personally, I have received invitations for people to say you take over this part and do this work. So I know that when you build relationships, it is possible. So build that
Hmm.
and you can do those experiments. Once you've done experiments, you've convinced yourself that this works, then you can go and invest there or figure out ways there. It is very much smart. You can smartly figure it out, but you'll have to work a long run. In Hyderabad, there are a lot of people who are working in Infosys and in CTS and doing weekend farming and doing experiments and doing a lot of things. I can connect you to a lot of Hyderabad based farmers, and in Pune also there are a lot of farmers networks there. I am also managing a community called Code to Croppers. I'll share details around that. That community is also, if you join System, you should be able to get that as well. So yeah, you can check that out as well. Yeah, sir, you want to add anything else?
Hyderabad, do you know about RYSS?
Yeah, 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 yeah. Yeah, Vijay Kumar Garu,
Abhijay
I
Umar
do.
Garu.
Yeah, yeah, yeah,
Yeah,
yeah,
I know him. We have, I know him.
yeah. Okay,
Visited him.
nice, nice. Yeah, yeah. we've met in a couple of brief meetings per se in Perth, but great, sir. Thank you. I'll turn off the recording and close this podcast for now.
Okay.
But yes, if there any last suggestions or recommendations to Shrikant for based on what his question are, anything you want to say before we close?
Yeah, I think what you said is exactly. I agree with what you said to
Okay,
Srikant.
okay.
Yeah,
Thank you so much, sir. I'll close the recording and I'll close the podcast for now. Yeah, thank you so much.
Thank you.